This is the problem counting tilings. So here our task is to count the number of ways to fill the n cross m grid using these two tiles, which is a 1 cross 2 tile and 2 cross 1 tile, right? So let us understand through this a sample test case, right? If I am taking a 4 cross 5 grid, see, you need to fill this whole matrix. You need to cover this whole matrix with this two tiles, right? Which is a 2 cross 1 tile and another 1 cross 2 tile, right? So what I'll try to do is I'll try to fill each column by column. Each column by column, I'll fill it completely. Like if I'm approaching this column, my main aim will be filling out this column completely. Then I'll move to the second column and I'll try to fill this column completely, and then I'll fill this column and I'll move forward. So I'll move forward like that. So if see here, if I filled these two tiles like this, if I have filled this two cross one tiles, then I can move here and I can again place, and there won't be any problem if I can place these two tiles like vertically, right? But where the problem actually occurs is if you have placed, see here, if I have placed this 1 cross 2 tile over here and this 2 cross 1 tile over here and this 1 cross 2 tile over here, right? If you have placed like that, then here your first column is completely filled, and when you're trying to move to the second column, and when you're trying to fill the second column, you need to know actual what are the actual blocks that have been already occupied by the previous horizontal blocks, right? By the previous horizontal blocks, you need to make a track of that, right? So here, while you are filling this first column, make sure when you're you have, like, just take a visited vector, like whenever you're filling a horizontal block, that means the next block has also, see here, whenever you're placing a horizontal block, then the next block has also already occupied, right? So in that cases, you just mark that position so that you won't place any block when you get into the next column over there, right? And if you're see here, I have placed horizontal blocks, so there won't be any block occupying in my next column. And when you're trying to place a horizontal block again, then here my next block has been occupying. So you can, like, while filling this blocks, just make sure that you have already been constructing what are the blocks that have been occupied in my next column, right? So just make sure that you keep a track of that. And see here, when I'll go over here, I have this visited vector, right? So what, here I have whatever the blocks that are empty, and I have also I have also the blocks which have been already occupied, right? So I'll check whether, if my current block is empty, then I can try to place a block like this, or I can check whether my next block is also empty. Then I can place a vertical block like this, right? Then I can place a vertical block like this. So you can do like this, you can fill the columns and you can construct the next visited column, so that you can know in the beforehand what are the columns that have been occupying in my next column, right? But when in the larger cases, when you try to when you try to optimize this, or when you try to memorize this through a dynamic programming, memorizing through a vector can become a problem, right? It can become a problem. So what we will try to use over here is the bitmask dp, right? The bitmask dp, like how we will be using. See here, when you are filling this current column, your next column is your next column will be 1001, right? So instead of sending this vector, I'll convert that into binary representation, and I'll convert that into a decimal, right? So I'll send 9 to my next column. So here, when I'm reaching over here, uh, I have 9 with me. I have 9 with me, and I'll check the binary representation of this 9. So here, in 9, you have first block. See here, like here the first block has been 1. That means this cell has been already occupied, and you come to the second position and you check. If it is a 0, then you know it is one of the empty block over here. Then you come over here and you know you can check, this is also an empty block over here. So that is what the main intuition over here. See here, if I try to place like these two horizontal blocks in this column, if I have placed two horizontal column blocks over here, so I have completed filling my second column completely, and now I'm moving to my next column. So whenever I'm moving to my next column, I'll send here 6. Why I'm sending 6? Because 0110 is a binary representation of 6, right? You can check, like this is 2 power 0, 2 power 1, 2 square, 2 cube. You can just multiply this, and you can get the value 6, right? So so here I'll send 6, and now in my I'll send 6 to my next column, and I'll check and I'll check. See here, I'll come to my first block, and it is indicating me here the bit is not set in the 6. So what it is indicating? It is indicating that particular row has been empty. If that bit is set, you know that particular block has been already occupied in that particular row. So similarly, you'll check like that. See, so if two consecutive zeros in the binary representation are appeared, you can place a vertical block. You can place a vertical block like this. Or if only a single block, uh, or a single zero is appearing, you can place a horizontal block like this here. So that is what the main observation you need to make, like how we are, instead of sending a visited vector, you're sending a number with a binary representation. When you're converting that number into the binary representation, you're actually getting the visited rows, right? What are the blocks that have been already occupied in that current column? You're getting through that number. So so you know, let us understand through an actual test case. See here, I have taken a 3 cross 4 grid. Here I have taken a 3 cross 4 grid. See, initially I'll be sending okay, I'll erase this. Yeah, initially I'll be starting over this first column, and you know I'll send 0. What is this 0? It is representing me that you know this, in the first column, not even a single block is occupied. Like it is indicating what are the blocks that have been occupied in my current column. Okay, so now see here, uh, in the first row I'm getting 0. I'm getting 0. That is indicating me like in my current column, no such block is occupied currently. Now, what are the ways that you can fill this first column? Either you can place a 2 cross 1 tile, right? Either you can place a 2 cross 1 tile and 1 cross 2 tile like this, or you can place a 2 cross or you can place a 1 cross 2 tiles like this, or you can fill away like this, right? So here I have filled my first column completely, right? Here I'm filling my first column completely. So whenever you're filling the first column completely, then what will be my next column? What about my next column? Like you need to send some indicator, like what are the cells that have been occupied in my next column, right? So here what I'll try to set is, here I'll try to set 1. I try to send 1 here. See, when I'm moving from this column to this column, I'll send 1. What it is indicating? It is indicating that this block has been already occupied, right? See here, while moving this block to this block, I'll send 7. Why I'm sending 7? Because if you look at this column 2, then you can get triple one, which is a binary representation of 7. So that's what I was sending 7 to my next column, so that it indicates what are the blocks that have been occupied in your column, right? So when you're moving, see here, from while moving this first column to second column, like I'll be sending 4. Like why I am sending 4? Because 100 is a binary representation of, because 100 is a binary representation of 4, right? So I'll be sending these numbers. I'll be sending these numbers, which will indicate what are the blocks that have been already occupied in my current column. So here, now you're here at this second column, and now what are the ways to fill this second column? Like either you can place a two either you can place a vertical column over there, or you can place two horizontal blocks like this, right? Or you can place a two horizontal blocks like this. Now see, here your second row has been completely filled, and now while moving to the third block, you'll send 0. Why? Because triple zero is a binary representation of 0, right? Right. Now here I have filled my second block completely, and now when I'm going to the third block, here you can see which is 011. That means 110, which is a binary representation of 6. So I'll send 6 to my next column. So whenever you try to fill, just check this ayat position of this number. If you check the binary representation of that ayat position, then it will tell you whether the current position has been already occupied or not, right? So here, like that. And here, while filling here, the second column is completely filled, so we won't make any changes. So we'll just send 0. We'll just send 0, which indicates all of the blocks are empty in my next column. Now if you come through like this, here you can place a horizontal block, or you can place a vertical block, or two horizontal blocks like this, right? So when you try to fill this, here your next column all are empty, so that will you'll just send 0 over here. Or otherwise, while filling this block, you have already completed your second column. Now for the next column, you just send this number, which is 011, which is nothing but a 3, right? Which is nothing but a 3. it indicates you the starting two blocks have been already occupied by placing horizontal blocks, right? By placing horizontal blocks previously. So the whatever the number whatever the number I was sending, it is actually indicating me what are the blocks that have been already occupied in my current column, right? In my current column. So you just try to fill like that, and you just go to the ending. So yeah, each time you'll be giving this next, you'll be building this next column and sending it as a binary number, which whose binary representation will indicates you like what are the particular positions that have to be still need to be filled, right? What are the like it indicates you like what are the positions that you have to fill it accordingly, right? So here, so this is what the main flow looks like. And if I have to conclude you with a base case, like, here we are filling this 3 cross 4, right? Let us say some random cases here. If we are filled a matrix like this, and this last two have zeros, that means you'll be having 4 as your current number, which indicates you this last position has only this last position has only filled, right? So you check, so you write, so whenever you have already some number with you, you just write the binary representation of that. So you check the ith bit, which is, see, here 0 1 2. You check the 0th bit, which is a 0 in this 4, which is a 0 in this 4. That means it indicates you it is an empty block, right? It is an empty block. So you can place a block like this. So while you are filling this current column, parallelly you construct the next, you just construct the next number, right? You just construct the next number. So here, whenever you're placing a horizontal block, then can I say your next block will also be occupied in the next column. So in such cases, your next mask. See, I was constructing the next number. To indicate what are the columns, to indicate what are the blocks that will be occupied in my next column. See here, if I try to place a horizontal block, then I'll add this 2 power 0, right? This 2 power 0, which is a presently 1, which is a present 1. And even if I'm placing a one more horizontal block, then I'll be adding 2 power 1. I'll be adding 2 power 1. So here the last block has been already completely filled. So what is this summation? That is 3, right? That is 3. Now if you write the 3's binary representation, it will give you 0 double 1. It will give you 0 double 1, which means, see here, you'll get your next column as like that. So that means what it is indicating, in your next column, your first row will be occupied, your second row will be occupied. The only space that have been left is in the third row. So that is how you are using this numbers as binary representation, as a visited vector, which shows what are the blocks that have been already occupied and what are the blocks that have been empty, right? So here, see, if it is this last block, and if it is ending over here, so while you're constructing this next number, can I say it has to be 0? It has to be 0 for sure. like if you're getting something like a 3 or something, that means, can I say, it is getting overflowed by placing this horizontal blocks. It is getting overflowed by placing these horizontal blocks, right? So that is one case. Like whenever you're reaching the end of the array, your current number should always filled with zeros. That means, while that means you have successfully completed till before, right? So that is how it will be. So I'll just quickly go through my code. Yeah, see, initially I'm just taking this m and n input, and here this is my current column, which is, you can see over here, this is my current column, and this is my current mask, which is my current number. What it is indicating, it is indicating me what are the number of what are the empty blocks and what are the occupied blocks in my current column. See here, initially I'm sending 0. That means it is indicating in my first column all blocks are zeros. All blocks are zeros. No block is occupied yet, right? So here what I was trying to do is, I'm trying to construct all the possible ways, and I'll construct the next number. What will be my next mask? What will be my next number? What will be my next number? uh, so that you can calculate the next call function. See here, your next number, if you have constructed your first column in this way, your next mask will be a 1, right? This number, a 1. Or if you have placed the tiles like this, your next number will be 7, right? Which is 3 ones. If you have placed your if you have filled your first column in this way, then your next column, then your next number will be 4, right? So I was calculating those next numbers, and I'm storing in my next vector. So here, while I was filling 1, uh, when I call this calci function, it will stores 1, 7, and 4. 1, 7, and 4 in my next vector. So what it is trying all the possible ways to fill my current column. It is trying all possible ways to fill my current column, and it is generating what could be the next mask, which is indicating you what could be the next visited column. Like you got the intuition, right? So if you go through this calci function, here you can check. See, first of all, you'll check whether your current bit is set or not. You Here I was sending my current mask, right, which is this one. Yeah. So here it is indicating you, like, if you have come over like this with a 1, so what you if you can check the first position, it will give you a 1, right? So here, if I need to tell you, like, here I was taking this mask, which is a 001, right? Here, uh, here you need to know this bit. Like, I was checking the ith bit. What is the current bit in my ith row in that number, right? Here, see, here in my first position the bit is set. Here my first position is set. That means it is already occupied. Now what I'll try to do, I'll go to second index, and I'm just checking these two consecutive values, which is, see here, if I need to write here, you can write simply like this, 100. Okay, 100. So here I have checked the first bit. Here I have checked the first bit, which is set bit. So I just leave. So if my current bit is set, I'm just moving to my next I'm just moving to my next row. I'm just moving to my next row. So that means from this row to I have just moved to this next row. So now what I was trying to do, I was just again calculating my current and the next bits which are set or not. So here this bit is not set and this bit is not set. So if my bit is not set, then can I say I can place a horizontal block over there? I can place a horizontal block over there. If I'm placing a horizontal block, then you can just simply move to the next row. See here, if you are placing a horizontal block like this, then you can just simply move to the next block while while adding this number to your next mask. So you need to turn this position, you need to turn this bit position on in your next mask, right? So here whenever I was placing a horizontal block, i'm just I'm just turning on that bit in my next mask, and I'm moving to my next row, and I'm moving to my next row. Or otherwise what I can do is something like, see here, if your x is 0 and if your y is 0, right? If your x is 0 and your y is 0, what is y? That is my I plus 1th bit. I plus 1th bit is set or no. If both bits are not set, can I say I can place a vertical block? I can place a vertical block like this. I can place a vertical block like this, and I can jump two positions. I need to jump two positions, right? So here I was checking whether my next bit is not set, and there exists a next row, right? And there exists a next row, and it is not set. If that is the case, I was jumping two rows next, and your next mask will not be affected. Why? Since you are placing a vertical block, it won't affect you the next column, right? So that's how, see here, this is uh, this is a horizontal block. If I need to write, yeah, this is a horizontal block placement, and this is my vertical block placement. So yeah, this is my horizontal block and this is my vertical block, and this will be the case which have been already occupied. So this block has been already occupied because of my previous horizontal block, right? So yeah, this is the case. So you just simply go through all this. So whenever you reach the end of the row, that means see here, after this you're reaching the last position. That means you have completely filled like this. So while filling this, what is the next mask that you have got, right? So that is the next mask I was storing in my next vector. That is, I was storing in my next vector. So you just compute all these possibilities, whatever the next mask. So for all those possibilities, you just you just solve for again column plus one with that next mask. So if you reach the end of the array with your mask equal to 0, because when you're reaching the end of the array, it should be 0. When you're reaching the end of the column, it should be 0. Why? Because it can be overflowed, right? See here, if the place like this, then if you reach the end of the array, then you need to get all these zeros at this end of the position, then only you have filled it successfully, right? So yeah, that's what it is. I know i know it's hard, but my main aim is to give you some idea like how it actually works. Maybe you can't get it completely, but just try to go through the solution. I'll just give it to you in the description, and yeah, just try run through the test cases, and you can get what is actually happening behind. So yeah, if I run this, it does run fine. And if you need to yeah, memo is this. You can take this TP, and yeah, I just resize this with n columns, and each column, you'll be having 2 power m states, right? 2 power m states. Why 2 power m states? You can ask me. Why 2 power m states? See here, uh, like here, the number of rows are 3. Now, what are the binary representations you can get by using these 3 bits? You can get from 0 to 7. You can get from 0 to 7. It is nothing but 2 power 3 states, right? It is nothing but 2 power 3 states, which is from 0 to 7. So that is why I was taking, like we are converting that binary representations and sending, right? So that's why you will be getting 2 power n states, so you'll be filling with the minus ones. Yeah, here you just memorize this with column and mask. If that is not equal to minus 1, then just simply return this mask, or otherwise, yeah, you just simply store it with this answer. Yeah, if I run this, yeah, okay, I need to keep a semicolon. Yeah, it does run fine. I can check you through the last test case. Yeah, you see, it does run fine. Yeah, I just give you this code. Just make sure you go through it. I can, you can get a basic idea. Like, if there's still any doubts, just comment me down. I'll be happy to reply you.